Mercury. Mercury is the smallest planet in the solar system, with a diameter of approximately 4,880 kilometers. It is only slightly larger than Earth's moon, and is the smallest of the terrestrial planets, which include Mars, Venus, and Earth. Mercury is also the closest planet to the Sun, with an average distance of approximately 58 million kilometers or 36 million miles, which is about 0.39 astronomical units. Its distance from the Sun varies due to its highly elliptical orbit. Because of its proximity to the Sun, Mercury has a very short year, lasting only 88 Earth days. However, its slow rotation means that a day on Mercury lasts much longer, approximately 176 Earth days. This means that a year on Mercury, or one full orbit around the Sun, is actually less than 2 Mercury days. One of the most interesting features of Mercury is its extreme temperature variations. During the day, when the planet is facing the Sun, temperatures can reach up to 430 degrees Celsius, while at night, when the planet is facing away from the Sun, temperatures can drop to as low as -180 degrees Celsius. Mercury's orbit around the Sun is also unusual. Rather than being a perfect circle, like most of the planets in the solar system, Mercury's orbit is an ellipse, which means that its distance from the Sun varies over time. At its closest approach, Mercury is only about 29 million miles or 47 million kilometers from the Sun, while at its furthest point, it is about 43 million miles or 70 million kilometers away. This means that the planet experiences significant gravitational tugging from the Sun, which can cause its orbit to precess over time. Mercury's surface is heavily cratered and resembles the Moon's surface. This is due to its lack of an atmosphere, which leaves it vulnerable to impacts from asteroids and comets. The largest impact basin on Mercury is called the Caloris Basin, which measures about 1,550 kilometers or 960 miles in diameter. It was likely formed by a large asteroid or comet impact early in the planet's history. The impact that formed this basin would have been equivalent to the explosion of 1 trillion tons of TNT. Mercury's surface is covered in a layer of regolith, which is a mixture of dust, rock fragments, and impact debris. This layer can be several meters thick in some areas and is thought to have been formed by a combination of impact processes and the gradual breakdown of rocks due to exposure to solar radiation. One of the most unique features of Mercury's surface is its long, steep cliffs called scarps. These are thought to have been formed as the planet cooled and contracted, causing the surface to crack and shift. The largest scarp on Mercury is called the Discovery Rupees, which measures about 1,200 kilometers or 750 miles in length and up to 3 kilometers or 2 miles in height. Mercury's surface is also marked by a variety of other features, including smooth plains, craters with central peaks or complex floors, and volcanic features such as lava flows and vents. Some of these features suggest that Mercury was once a much more active planet with a more dynamic geology than it has today. Mercury's interior is dominated by a large iron core, which makes up about 70% of the planet's mass. This core generates a magnetic field that is about 1% as strong as Earth's. The presence of this magnetic field was a surprise to scientists, as it was not expected in such a small planet with a relatively cool interior. Because of its small size and lack of atmosphere, Mercury has a very weak gravitational pull. If you were standing on Mercury's surface, you would weigh only about 38% of what you weigh on Earth. Mercury has a very tenuous atmosphere, or exosphere, that is not similar to Earth's atmosphere. It is so thin that it is often considered to be essentially non-existent. The exosphere of Mercury is composed mainly of helium and hydrogen, as well as small amounts of sodium, potassium, and oxygen. These gases are thought to be the result of particles being stripped from the planet's surface by the solar wind, which is a stream of charged particles emanating from the Sun. Because of its weak gravitational pull and lack of a substantial atmosphere, Mercury cannot retain these particles for long. Instead, they quickly escape into space, leaving behind the planet's rocky surface. The lack of a significant atmosphere also means that Mercury has no weather patterns or seasons, and its surface is constantly bombarded by meteoroids and other space debris. This has led to a heavily cratered surface with many geological features, including impact basins, scarps, and ridges. Despite its thin exosphere, Mercury's magnetic field is relatively strong for a planet of its size. This magnetic field is generated by the planet's partially molten iron core, which is believed to be responsible for the formation of the field. Mercury experiences a phenomenon known as gravitational lensing, which causes the Sun's gravity to bend light around the planet. This effect was first observed during the Mariner 10 mission and has since been studied in more detail using ground-based telescopes. Overall, Mercury's atmosphere is very different from Earth's, and its thin exosphere does not provide any significant protection for the planet's surface from the harsh conditions of space. Mercury is primarily composed of rock and metal. This means that the majority of its mass is made up of solid materials, rather than gases. Specifically, Mercury's composition is about 70% metallic and 30% silicate rock. The metallic portion of Mercury's composition is made up mostly of iron and nickel, which are heavy elements that tend to sink toward the center of a planet as it forms. This is why Mercury is the second densest planet compared to other planets in the solar system. Overall, Mercury's composition is similar to that of the Earth's moon, with a heavily cratered surface and a large, partially molten iron core. However, its small size and close proximity to the Sun make it a unique and fascinating object for scientific study. Despite its proximity to the Sun, Mercury is a difficult planet to observe from Earth because it never strays far from the Sun in the sky. Because of this, it can only be observed during certain times of the year when it is visible just before sunrise or just after sunset. The best time to observe Mercury is during one of its transits, when it passes directly between the Earth and the Sun and appears as a small black dot moving across the Sun's disk. These transits occur only about 13 times per century and are visible from different parts of the world depending on the specific geometry of the Sun, Earth, and Mercury. The first spacecraft to visit Mercury was Mariner 10, launched by NASA in 1973, which flew by the planet 3 times and returned detailed images and data on its surface and atmosphere. The Messenger spacecraft, launched in 2004, orbited Mercury for 4 years and collected extensive data about the planet's surface, geology, magnetic field, and atmosphere. Messenger was also the first spacecraft to visit Mercury since Mariner 10. Bepi-Colombo, a joint mission between the European Space Agency and the Japan Aerospace Exploration Agency, was launched in 2018 and is expected to arrive at Mercury in 2025 to provide more in-depth information about the planet. Bepi-Colombo consists of 2 spacecraft that will orbit Mercury and study its surface, magnetic field, and interior structure. These missions have significantly advanced our understanding of Mercury and provided valuable insights into the planet's geological history, magnetic field, and composition.